Hello again, grade 7s. In today's lesson, we're going to continue to look at independent events. And in doing so, we'll continue to represent them both with tree diagrams and tables and do probability calculations associated with them. The only real difference today is we're going to look at problems that are just a little bit more difficult in terms of the wording of the problems and just some other things that the problems are going to want us to accomplish. Let's start off with this example. It says the following tree diagram shows the outcomes when a spinner is spun and a die is rolled. What I want to do here is I kind of want to work backwards because typically what happens is the problem shows us what the objects are. Like we would be shown what the spinner is and we'd be shown what the die is. And then we need to construct a tree diagram based on that. Well, this time it shows us a tree diagram and we want to go backwards and we actually want to construct both the spinner and construct the die. Okay, so we've got to make a bit of sense about this. So the question really is, are the numbers on the left-hand side for the spinner or the die? And the same thing with the numbers on the right-hand side. Are they for the spinner or for the die? It turns out for a die, the smallest number, the fewest number of faces you could actually have on a die would be 4. So there's no possible way that these trunks right here, the 1, 2, and the 3, the trunks of the tree could be the die because you can't have a 3-sided die. So this is going to be the die, and this then must be the spinner. All right, so let's go ahead and draw these. So the spinner let's just draw a circle as best as we can. Draw a point at the center of the circle. And I'll try to divide it into 3 equal sections. So probably the easiest way to do that is just from the center, draw a vertical line going up. And then we have a line that goes down and towards the right and a line that goes down and towards the left. And then we're just going to number these different sections. We'd have section 1, we have section 2, and we have section 3. So we spin that spinner, you can land on a 1, a 2, or a 3. As for the die, a 4-sided die, again, is like you have a pyramid, except the base of a pyramid is a triangle. So the way I'd construct that is I draw the base first. So we can draw this triangular base. And then we can draw like the apex of the pyramid somewhere up here, a little dot at the top. And then we'll have each edge just form a line all the way up to that apex. So we can have one line that goes up here like this. We can have one line that goes up here like this. And then one final line which goes from that back edge up to the very top. And that's my 4-sided die. Now I want to calculate the probability of spinning and rolling the exact same number. Okay, so we'll put down probability. And in brackets, we'll clarify what we're trying to do. We're trying to obtain the same number on the die. That's equal to your number of favorable outcomes divided by your number of possible outcomes. The number of possible outcomes is the total number of branches on the trees. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, my favorable outcomes is obtaining the same number both on the spinner and the die. So in this tree, on this tree at the top here, you would need to get a 1 followed by a 1. On this tree, you would need to get a 2 followed by a 2. And on this tree, you'd need to get a 3 followed by a 3. So there's 3 favorable ways you can get the same number both on the spinner and on the die. So the number of favorable outcomes would be 3. If we calculate this, 3 divided by 12 is going to be a terminating decimal number, which is 0.25. And if we convert that into a percentage, this would be 25%. And we do that by moving the decimal spot 2 units to the right or by multiplying by 100. So this one, not too bad. The next one's a little bit more complicated. Maggie spins the spinner shown and then rolls a 6-sided die. And I want to express the sample space with a tree diagram. Now, this is going to be quite a big tree diagram. So I like to always do the trunks of my tree with the object that has the fewer number of outcomes. So that's going to be the spinner. The spinner has 3 outcomes, and the six-sided die has 6 outcomes. So let's put down a little heading here. We'll say spinner. And we have the number 1, we have the number 2, and we have the number 3. Those are the 3 possible outcomes on the spinner. Now we'll branch this into the die, and the die has 6 possible outcomes. So we can have 1 followed by 1, 1 followed by 2, 1 followed by 3, 1 followed by 4, 1 followed by 5, 1 followed by a 6 on the die. Same thing for these trunks of 2 and 3. So you have a 2 and a 1, you have a 2 and a 2, you have a 2 and a 3, you have a 3 and 2 and a 4, you have 2 and 5, and you have 2 and 6. And the final one, you would have 3 and a 1, you'd have 3 and a 2, you'd have 3 followed by a 3, 3 followed by a 4, 3 followed by a 5, and 3 followed by a 6. So that's my completed tree diagram. And like I said, the tree diagrams are generally, I think they're the fastest way to represent the different outcomes, represent the sample space. And they're also going to be useful in the event that the problem asks you to do something a little bit different. And that's what this problem is going to do. But we're not there yet. Okay, I want to calculate the probability of spinning a 1 and rolling at least a 2. So you got some weird language here. It says rolling at least a 2. Now, what that means is at least a 2 is the same thing as getting greater than or equal to 2. So at least 2 means that's the lowest number that's possibly acceptable. So the lowest number that's acceptable would be a 2. And any numbers bigger than that are also acceptable. So at least 2 is greater than or equal to 2. So let's set the probability calculation up. So we're going to say the probability of spinning a 1 on the spinner. And then at least 2 means getting greater than or equal to. So put the greater than sign and then an underline to show that's equal to. Greater than or equal to 2 would be equal to favorable outcomes over possible outcomes. Now, we got to go back to the tree diagram to determine this. So the possible outcomes, if you count them, are the number of branches on the tree. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 of them. Okay, so you got 18 possible outcomes. Now, the favorable outcomes are getting a 1 on the spinner and a number that's greater than or equal to 2 on the die, which means at least 2. So let's identify that. How many ways can I get a 1 on the spinner and a number that is at least 2? At least 2 is greater than or equal to 2. Okay, so that would be 1 followed by a 2, 1 followed by a 3, 1 followed by a 4, 1 followed by a 5, and then 1 followed by a 6. Okay, so again, that's getting a 1 on the spinner and a number that is at least a minimum of a 2. And anything bigger than that's acceptable. So there's 5 favorable ways I can obtain that. So now let's go back and perform the calculation. So we have 5 over 18. Now, this is going to give you a repeating decimal number. So we're going to have to do some rounding here. So 5 over 18 is 0 decimal 2 7 7 7 7 7, and it just repeats on from that point. To round this, we want to look at the third decimal place. So that's going to be this one right here. And to round it, you have to look at the following digit. So the following digit, when again, we want to round to the nearest thousands, we're going to look at that following digit. If that digit is a 5 through a 9, it means we have to round this digit in the thousands position up by 1. So we're actually going to round the 7 up to an 8. So this would then look like 0.27, and then an 8. To turn that into a percentage, multiply by 100, move the decimal spot 2 units to the right, and that would be 27.8%. Now, see where it gets a bit more complicated. It says, in an extra column in the tree diagram, determine the products of the two outcomes along each branch. Okay, products means we're going to do some multiplication. So let's go back here, and we're going to add a third column now, and we're going to call this column product. What that wants me to do is it wants me to take the number in the trunk of the tree, and it wants me to multiply by all these numbers in the branches. So we're going to have to do this 18 times. So we're going to go 1 times 1, which would be 1. 1 times 2, which would be 2. 1 times 3 would be 3. 1 times 4 would be 4. 1 times 5 would be 5. 1 times 6 would be 6. 2 times 1 would be 2. 2 times 2 would be 4. 2 times 3 would be 6. 2 times 4 would be 8. 2 times 5 would be 10. 2 times 6 would be 12. And then this one right here, it would be 3 times 1 is 3. 3 times 2 is 6. 3 times 2 is 9. 3 times 4 is 12. 3 times 5 is 15. And then 3 times 6 is going to be 18. So I calculated every product by taking the value in the trunk of the tree and multiplying by the value at the end of the branch. Okay, that's my third column with the product. Now let's see what it wants us to do with this. Determine the probability of spinning a 3 and obtaining a product that is at most 10. Well, let's first of all deal with that language there. What does it mean to have at most 10? Most 10 means that is the maximum number that you are allowed. Okay, you're allowed to have a 10, and any number that's less than the 10 is okay. So if I word this, at most 10 means that you're looking for a number that is less than or equal to 10. So let's set up our work here. I want the probability of spinning a 3 on the spinner, and I want a number that is less than or equal to 10. So we'll draw the less than sign. We'll put the underline beneath it to show that it's less than or equal to 10. And that's equal to my number of favorable outcomes divided by the number of possible outcomes. You still have 18 possible outcomes. Oh, and by the way, this is a product. So it's not just 3 and less than or equal to 10. It's a product that is going to be 3 or less than 10. So let's maybe just clarify that. So it's a product yeah. Let's fix this up a little bit here. I'm actually going to erase it. Let's do this. Okay, so spinning a 3 and then getting a product that is less than or equal to 10. All right, so that's equal to your number of favorable outcomes divided by the number of possible outcomes. If I go back to the previous page, okay, I calculated 18 products. Okay, I did that 18 times. That's the number of possible outcomes. Now, I want to identify how many ways can I get a 3 and then get a product that's less than or equal to 10. Well, let's take a look at this. Okay, so we're going to focus right here on this 3. So I want a 3 followed by a number that is less than or equal to 10. Okay, so which numbers are less than or equal? It's a 3 here, and we're going to focus on this one. Okay, the product column. A 3 and a product that's less than or equal to 10. Well, 9 is less than or equal to 10. 6 is less than or equal to 10. And then 3 is less than or equal to 10. Okay, so if we go back to this here, product that's less than or equal to 10, there's only going to be, how many ways do we identify? there's 3 ways you can get that. So it's going to be 3 over 18. Okay, so 3 over 18. This is going to give you a repeating decimal number. So 3 divided by 18. So 3 divided by 18, this should give you a repeating decimal of 0.16666 repeating. Okay, now we need to round this. So we want to round to the nearest thousand. That's a third decimal place. We have to look at the digit that follows. The digit that follows is again, if it's a 5 through a 9, that means you have to round that thousandths digit up. So we do need to round it here. So this would then be 0.167. We round this 6 up to a 7. And if I convert that into a percentage by multiplying by 100, it would then be 16.7%. So like I said, a little more difficult because you need to interpret the language where you see the words at least and also at most. At least means greater than or equal to that number. At most means less than or equal to that number. And then just some extra like things here where we can make like a third column where we either determine like sums or products. And then based on that, it's going to make some of the calculations perhaps a little bit more difficult just because you need to interpret the tree diagram and the additional column a little bit more carefully. All right, that's it for this lesson. You can complete page 181, numbers 3 through 8. Again, I really recommend, I said you can, if it says ask you to draw a tree diagram, you can do a tree diagram instead of a table or vice versa. Again, I recommend for the most part doing the tree diagrams, especially if you have a part of the question that says something along the lines of like do a third column to represent a sum or do a third column to represent a product. And I'll talk to you in the next lesson.